Hello everyone and welcome to Gradeup. My name is Ashish Sir and today we are here to discuss, on the soil mechanics class 2. Okay, so today we will be discussing about permeability. Previously we have done one session of soil mechanics. In that we have discussed soil properties. I hope that session was helpful to you. Now in this session we will be discussing, we'll be moving to a new topic, that is permeability. Now before that I would wait for more viewers to join this session. So I am getting a lot of queries now regarding some of the students, they are having a point of view regarding this RRB JE exam, that it will be held in the month of April or May as given tentatively in the notification. Okay, so since as you all know the general elections are going on, so there's a very low probability of exam being conducted in the month of April, in this month and the coming month May. So most probable date of this CBT1 would be around the month of June. Okay, so this could be the month, okay, in which this exam would be conducted. Definitely in April it won't be conducted, and since the final result, the elections will be on the till the last week of this May. So on 23rd there is this counting of the votes. So I don't think this exam will be conducted in the month of May. So June may be the probability of this exam. So right now you should also focus on this CBT2 exam, because you know that this CBT1 is of qualifying nature only. Okay, so give your focus on CBT2 for this time being also. Okay, yes, Vishal Datta, good evening. What about SSC JE? See, SSC JE is very it is not very predictable exam, so it cannot be we shall wait for the official dates. Right now predicting that won't give any justice. It won't give any justice. Okay, Makroof Ahmed, yes, good evening. Okay, so let's start the session. Okay, so introduction to the permeability. Now first of all, what is permeability? The definition is very important, and as it is written over here, permeability is the property of soil, okay, by virtue of which it allows the flow of fluid. Okay, so fluid, generally it is water in the soil. Okay, so it is this property by which the fluid is the water is flowing through the soil. Its permeability is that property. Now it is also known as hydraulic conductivity. Now you know conductivity is generally set with this current, okay, electric current. Okay, so current is the thing which flows through the wires. Okay, so conductivity is referred to the current in electrical equipments. Hydraulic, you have attached this hydraulic word, that is with respect to water. So water, it is allowing water to flow through the soil, so that is the permeability. Okay, so that's why it is also termed as hydraulic conductivity. Now depending on the type of soils, the permeability varies. Okay, so gravel, so you know the coarsest of this soil is gravel. Now the permeability of gravel is greater than 1 centimeter per second. Now this is centimeter per second. Okay, so you may think that this is very low, but from the soil point of view, the flow of fluid in soils, this is very high. 1 centimeter per second is a very high speed. Okay, now for sands, it is 1 to 10 raised to power minus 3 centimeter per second. Okay, now for silt, it is 10 raised to power minus 3 to 10 raised to power minus 7 centimeter per second, and similarly clay, it is less than 10 raised to power minus 7 centimeter per second. So as this is becoming finer, okay, the permeability is decreasing. Permeability decreases. Okay, so as the soil is getting finer, the permeability is decreasing. Okay, now the one law which you might have heard in your colleges, okay, with respect to the soil mechanics and permeability, is Darcy law. Okay. Now, what are the assumptions in Darcy law? Flow is laminar and soil mass is saturated. Okay. So, this is the flow is laminar, okay, and for soils the Reynolds number must be less than 1, okay, and soil mass is saturated. Now, the Darcy law states that velocity of flow is directly proportional to the hydraulic gradient, okay. It is similar, this Darcy law is similar to the Ohm's law in the electrical engineering, okay. So, here it is, the velocity is directly proportional to the hydraulic gradient. There it is, velocity is directly proportional to the current. Velocity, the voltage is directly proportional to the current. That's why we also termed it as hydraulic conductivity. Okay. So if you remove the constant of proportionality, it is V is equals to Ki. Okay. And where K is coefficient of permeability. Okay. Now, discharge Q is area into velocity, okay, and velocity is K into I. So, KIA becomes the expression for discharge, okay. Now, see, if this is a soil mass, okay, so let us suppose it is composed of particles like this, okay. So, this is the soil. Now, this is having voids in it through which the flow of water will occur, okay. The water will flow like this, okay, through voids, okay. So, the velocity which is given by Darcy is the average velocity. In actuals, through these particles, the water is not flowing, it is flowing through the voids. So, there is a certain volume or area of voids through which water travels, okay. So, the actual seepage velocity is much more than, the actual velocity will be much more, okay, because it is not flowing through the total area, it is flowing through an reduced area. So, discharge will remain constant. See, discharge is KIA, okay. So, discharge is KIA, discharge will remain constant, whatever was earlier it will remain same, this is same. So, we are saying that area is less, actual area is less. Hence, for same discharge, velocity is more, okay, and that velocity is known as seepage velocity Vs, and that is equals to V by N, okay, where N is porosity, okay. Now, V is equals to Ki, okay, and Vs is equals to Kp into I, okay. And from this expression Vs is equals to V into N, we can write Vs is equals to, we can put the value of V here in this expression. If I put the value of V, it is V by N, okay, wait, V is equals to Ki, okay. So, here we can write Vs into N is equals to Ki, or Vs is equals to K by N into I, okay. So, if this is first, this is second, and if we compare these two equations, Vs, okay, I is I equivalent to I, okay. So, Kp will be equal to K by N, okay. And now here Kp is coefficient of percolation, okay. So, Kp is coefficient of percolation. Now, this was about the Darcy law. Now, there are various methods to determine the permeability, okay. So, first among these is constant head permeability test, okay. Now, this is suited for coarse grained soil, okay. This is for the coarse grained soil. Now, the formula which this uses is K is equals to VL upon AHT, where K is coefficient of permeability as already discussed. V is the volume of water collected, okay, in time t. This is volume of water collected from soil sample, okay, and A is the cross section area of the soil sample, H is the head difference, okay. So you may get objective questions from this formula also, okay. So from objective point of view, this formula is important. Now that was the constant head permeability test. This is falling or variable head permeability test. Now this is suited for fine grained soil, that is suited for the constant head permeability test is suited for coarse grained soil, while falling head is suited for the constant head is suited for coarse grained soils, while falling head is suited for fine grained soils, okay. Now the formula here is slightly different. It is K is equals to 2.303 AL upon AT into log to the base 10 H1 by H2, okay. It is totally different, not slightly, it is totally different. Now here K is the coefficient of permeability, A is cross section area of standpipe. Please take care of these areas, small a and capital A, okay, particularly in this formula. Now capital A is cross section area of soil sample, okay. H1 is the initial head difference and H2 is head difference after time t, okay. Now there is one more test which is not very popular, but from examination point of view it may appear, so it is imperative to discuss it here. It is capillarity permeability test, okay. Now this is suited for partially saturated soils, okay. Earlier the soils were completely saturated, this is suited for partially saturated soil. Now formula here is x2 square minus x1 square divided by t2 minus t1 is equals to 2 times of ku upon Sn into H0 plus Hc. Now here this x1 and x2 are the readings at time t1 and t2, okay. Ku is coefficient of permeability, S is degree of saturation, N is porosity, and H0 is initial head, while Hc is capillary rise, okay. So this formula is slightly complicated. It may not be asked as a numerical, but it may be asked for in form of MCQ. The correct formula for capillary permeability test is, or capillarity permeability test is suited for saturated soil, okay, partially saturated soil, dry soils, okay, like this. In this form they can ask the question, okay. So take care of these 3-4 points, okay. Then now these were the direct methods of determining the permeability, okay. The direct methods, first was constant head, second was variable head, third was capillary permeability, okay. These were direct methods. So now we will talk about the indirect methods. Now indirect methods, these are important from objective point of views, because directly questions appear from these equations, okay. These are empirical equations. Now first one is Kozny-Carbon equation. This is the most important equation and I will tell you why, okay. First of all, let's see the equation. K is equals to 1 upon Kk. This is constant of proportionality. This is just a constant of proportionality into gamma W upon mu into E cube upon 1 plus E into D square. Now gamma W is unit weight of water, mu is dynamic viscosity of water, okay. E is void ratio and D is particle size, okay. So here in objective questions the variation may be asked with respect to mu, gamma W, or with respect to the void ratio, or with respect to the particle shape. Also specific surface is equals to 1 upon D here, okay. So with respect to that also you can be, it is represented by SS, okay. So this equation is very important. Now comes Allen Hazen, it is comparatively less important to the cosmic carbon, but it is also. Navneet Chauhan sir, please explain more about gamma W. I don't think there is much to discuss about gamma W. Gamma W is unit weight of water, which is simply 9.81 kilonewton per meter cube. Okay, so it is standard value. Now Allen Hazen, moving to the Allen Hazen, it is K is equal to C D10 square. Now here one thing which you have to take care here is units. Okay, as I have written, where C is 100, this constant is equals to 100, D10 will be in centimeters and K you will get in centimeter per second. So please do take care. In exam it may give D10 in mm. You have to first convert and then only you will be able to get the correct answer, because this is an empirical equation developed by this scientist. So you have to take care of units, particularly in this equation. Okay. Now then, the third empirical equation is consolidation equation. Now in consolidation equation, K is equals to CV MV gamma W. There are three constants here. CV is coefficient of consolidation, okay, which we will study in the consolidation chapter. Okay. Then and MV is coefficient of volume compressibility. Gamma W, as I have already told, it is unit weight of water. Okay. Now then comes Terzaghi equation. K is equals to 200 E squared D E square, where E is void ratio and D is the size of sphere. Okay. So this is comparatively less important. Okay, you can leave this. Questions won't be asked from this. Only thing which is important from here is K is directly proportional to E square. So see, from cosmic carbon, K is directly proportional to E cube upon 1 plus E. So at times, if in RRB JE and SSC JE you will be getting virtual calculator, so that would be a problem there. But in some exams, the virtual calculator or any form of calculator is not present. In that case, if the variation is asked with respect to the variation of permeability is asked with respect to the void ratio, then you should quickly use this Terzaghi equation. K is directly proportional to E square. Okay, while if the calculator is present at your disposal, then you should use this equation, that is cosmic carbon. K is directly proportional to E cube upon 1 plus E. Okay. Mubaris is asking, D10 is effective particle size. Yes, D10 is the effective size particles. I have already told this in the previous lecture. Okay, in soil properties I have mentioned it. Okay. Then factors affecting permeability. Okay, so there are various factors on which permeability depends, or factors which affect permeability. Now first is particle size. Okay, so from cosmic carbon I know K is directly proportional to D square. Okay, so as the, what is this implying? As particle size increases, it leads to increased permeability. Okay, so this deduction which I have deduced is, as the particle size increases, the permeability increases. Okay, so that's why the coarse grained permeability is greater than fine grained permeability. Okay, then comes the particle shape. Now particle shape is specific surface, so it is indirectly proportional. So as the specific surface increases, permeability will decrease. Okay, then the void ratio from cosmic carbon itself. See, all these three deductions we have done from cosmic carbon. That's why I have already told you that cosmic carbon equation is very important. Okay, and you should know that very well. Okay, so as void ratio increases, the permeability will increase. Okay, the variation is with respect to this equation. Difference between D10 and DE. See, D is entirely different depiction. Okay, it is with respect to the equation predicted by Terzaghi, while D10, D60, D30 are entirely different concepts which have been developed with respect to the percentage finer. Okay, then the fluid particles, see, it is directly proportional to gamma W upon mu. These are the fluid properties. Okay, so as you all know, the viscosity is inversely proportional to temperature. So this implies K is directly proportional to the temperature. So as temperature will increase, the permeability will increase since viscosity is decreasing. Okay. Now with respect to degree of saturation, so K is directly proportional to degree of saturation. Now why? Why is it so? Since if there is high saturation, then there is lower air. Okay. Hence reduced resistance. Okay, and since resistance has reduced, so permeability will increase. Okay, with respect to entrapped gases, it will lesser the entrapped gases, more will be the permeability, because their path won't be get obstructed. Okay, with respect to foreign impurities, see, higher impurities may be in form of leaves, okay, any foreign material, okay, like plastic or anything. Okay, higher impurities will lead to lower permeability. Okay, then adsorbed water. So if there is higher adsorption, now what is absorption? Adsorption is, if this is a particle, the water will get stuck due to surface tension on its surface. Okay, so higher adsorption will decrease the permeability. And why? Because since it lowers the area available to flow. Okay, because since the particle size has increased due to adsorbed water. Okay, so the area, suppose there is another particle here, earlier their space was this much, but due to adsorption on both these surfaces, the distance has only left this much, so water will have increased resistance to the flow. Okay, so that's why permeability will decrease. So all these factors which I have told you right now, these are important from objective point of view. Okay, they may appear in form of theoretical questions or in form of MCQs. Okay. Okay. Now, permeability of the stratified soils. Okay, the soil may be in form of various layers having different properties. Okay, so in that case, the permeability of stratified, this concept you will have to apply. Okay, now flow parallel to bedding plane, this implies, okay, there is one more thing which is to be cleared here. Vertical flow, okay, at times, and horizontal flow. The depiction of permeability with respect to these is incorrect. Okay, you have to say parallel to the bedding plane. You cannot say this is for horizontal flow, permeability for horizontal flow and permeability for vertical flow. The correct depiction is flow parallel to bedding plane and flow perpendicular to bedding plane. Now this case is this one. If soil is like this, okay, so this is our soil and flow is happening like this. Okay, so this is Q here. Okay, now in this case, the head remains constant. Okay, so this is of Z1, Z2, Z3. Okay, this depths are Z1, Z2, Z3, and permeabilities are K1, K2 and K3 and so on. Okay, so head remains constant while Q is Q1. The flow is distributing in all these layers. This Q is getting distributed in all these layers, so it will be Q1, Q2, Q3 and so on. Okay, so Q will be equal to Q1, Q2 plus Q3. So average permeability will be equal to K1 Z1 plus K2 Z2 plus so on divided by Z1. This can also be written as summation of Ki Zi upon summation of Zi, I is equals to 1 to n, I is equals to 1 to n. Okay. Then flow perpendicular to bedding plane. Now if suppose the layers are like this only, okay, but flow is like this, okay. So in this case, as you can see, the flow will remain constant, discharge will remain constant, okay. It is not getting distributed. Properties are same, K1 Z1, K2 Z2, K3 Z3, okay. Now in this case, head loss, some of the head will be lost here, then here, then here, okay. So let it, this is H1, this is H2 and this is H3, okay. So in this case, the total head loss will be H1 plus H2 plus H3 and so on, okay. And K average is equals to Zi plus Z1 plus Z2 divided by Z1 by K1 plus Z2 by K2. In short, this can also be written as I is equals to 1 to n Zi divided by summation of I is equals to 1 to n Zi by Ki, okay. So this was the theory for permeability. I know it's a small chapter, but from objective point of view, it is very important, okay. And we shall now move to the questions, okay. Now the first question is, as you can see on the screens, you can quickly solve these questions, okay. A soil has a discharge velocity of 6 into 10 to the power minus 7 meter per second and a void ratio of 0.5. Its seepage velocity is sorry. Now seepage velocity is given to you 6 into 10 to the power minus 7 meter per second and void ratio is given to you. Void ratio is 0.5. You have to find the seepage velocity. Now porosity is from the chapter 1, E upon 1 plus E, okay. So E is 0.5 upon 1 plus 0.5, so that is 1 by 3, okay. Now seepage velocity is V by N, okay. V is how much? 10 to the power minus 7 divided by porosity is 1 by N, so that is 18 into 10 raised to the power minus 7. This will be meter per second. Take care of the units, okay. Yes, I am getting the answers. Yes, A is the correct answer. 18 into 10 to the power minus 7 meter per second, okay. Now the second question. Now stratified soil has 4 layers of thickness H1, H2, H3 and H4 and the corresponding permeabilities are this one, okay, 2, 3, 1 and 5. The average permeability perpendicular to the bedding planes will be, okay. Now here you have to find K average, okay, that is in vertical, this perpendicular to the bedding plane, it is also represented by V, okay. Now here you have to find Zi, summation of Zi by Ki, okay. So I shall put the values. Zi is 4 plus 1 plus 2 plus 3 divided by 4 divided by K1, that is 2, plus 1 divided by 3 plus 2 divided by 1 plus 3 divided by 5, okay. So K average will be equal to, this will be 10, this will be 2 plus 1 by 3 plus 2 plus 0.6. If you simplify this, you will be getting roughly about 2.03, okay. Yes, Vishal Datta, you have solved it correctly. So A is the correct answer to this question, okay. Yes. Now next question. Now in a falling head permeability test, okay, it is a falling head permeability test. Initially head was 50 centimeters and it drops 2 centimeters in 5 minutes. Find the time required to fall 25 centimeter in how many minutes, okay. So in falling head permeability test, the formula is 2.25 2.303 AL upon AT log to the base 10 H1 upon H2. Okay. So whatever be the head fall, okay, for no matter how much time you are taking, the permeability will remain same. The soil sample is same, so permeability will remain same. So for this, let us suppose this is case 1 and this is case 2. So for case 1 and case 2, K is constant. Okay. So if K is constant, that means 2.303, A will also be constant, length of sample is same, A into time is different. Log to the base 10 H1 upon H2 is equals to 2.303 AL upon AT2 log to the base 10, H1 is same and this is, let us suppose, H3. Okay. So let this is T3. Okay. So here this cancels out, these two also cancels out, A is also cancelling. Okay. So we are left with the equation 1 upon T1 log to the base 10 H1 upon H2 is equals to 1 upon T3 log to the base 10 H1 upon H3. Okay. So here T1 is 5 minutes, let's convert it into seconds. Log to the base 10 H1 was 50 divided by, it drops 2 centimeters. So if it is dropping 2 centimeters, that means head at this time T1 will be, after this 5 minutes will be 48. 50 minus 2, that is 48 centimeters. 1 upon T3 you have to find log to the base 10 H1. H1 is 50 centimeters and fall 2, that is 25 centimeters. So if you solve this, it will come out to be 5093.92 seconds, that is 84.9 minutes. Okay. So A is the correct answer. Yes, I am getting, yes, Abhijit, you have solved it correctly, very well. Okay. Just keep this in mind that permeability will remain constant since the soil sample is same. Soil sample you have not changed. Okay. So that is the key here. Also one more key is, it is dropping 2 centimeter. It has not dropped to 2 centimeter. It is dropping. So that means the head left will be 48 centimeters. Okay. Now we will move to the next question. This is a theoretical question. Now the factors which affect the capillary conductivity of the soil. Size of the voids, yes, it affects. Water content, definitely. Okay. And temperature. So all these three factors will affect the conductivity of the soil. Okay. Next question. Then now this question, you are given with the grain size. Effective grain size is 0.05. That means D10 is given to you and you have to find the value of K. So apparently you have to use Allen Heisen, and as I have already told, you have to take care of units here. So K will be equal to 100 D10 square, where D10 you will have to put in centimeters. So it is already given in centimeters, so just multiply that and this you will get 0.25 centimeter per second. The unit you will get is centimeter per second. Okay. So take care of this one. Okay. So A is the correct answer. Yes. Yes, I am getting correct answers to these also. Now next question. Now if the void ratio of soil medium is altered from 27%, so E1 was 27% and E2 is 15%. Find the percentage change in the permeability of soil medium. So you are required to find percentage change in permeability. Okay. Now here all other parameters are remaining constant. So that in this way you can say K is directly proportional to E cube upon 1 plus E. Okay. So K1 by K2 will be equal to E1 cube upon 1 plus E1 into E2 cube into 1 plus E2. Okay. So this will be the expression. So I am writing K1 is directly proportional to this and K2 will be directly proportional to this. Okay. So if you take the division, this will be the expression. So if I put the values, K1 by K2 is equals to E1 0.27 cube divided by 1 plus 0.27 into 0.15 cube into 1 plus 0.15. Okay. So if you simplify this one, you will get K1 is equals to 5.28 K2. Okay. So this is the value which you this is the relation between K1 and K2. Okay. So the percentage change in permeability is K2 minus K1 divided by K1 into 100. Okay, 100%. So K2 is okay. Okay, so yes. So K2 will be equal to how much? Okay, so K2 minus 5.28 divided by K2 divided by 5.28 K2 into 100%. Okay, so this will be coming in negative, that is minus of 81.6. Okay, now what is this minus indicating here? Negative indicates permeability will decrease. Okay, so 81.06, this is the closest option which you are getting. Okay, so this C will be the correct option. Now this is the last question for this session. Okay, so constant head permeability test with cross section area A. Okay, so A is given to you 10 centimeters square. When the flow taking place, hydraulic gradient is given to you, that is 0.5. Okay, also time T is given to you 60 seconds. Okay, and volume of water collected is 600 centimeter cube. Now you have to find the permeability. Now this is constant head permeability test. So the formula is VL upon AHT. Okay, so V upon A into H by L into T. So H by L is nothing but hydraulic gradient. So V is V upon AIT. Okay, so K is equals to, if I put the values, 600 centimeter cube divided by A in 10 centimeter square, hydraulic gradient is dimensionless and time is 60 seconds. Okay, so this permeability you will get in centimeter per second. So if you solve this, you will get 2 centimeter per second. Okay, so D is the correct option to this question. Suresh Vankudot, yes, Suresh, you have solved it incorrectly. Please take care of these units. Okay, somewhere you have done the mistake. So with this we have come to the end of this session. I hope this was helpful to you like previous session. Just watch all the sessions and practice the questions. Also these daily quizzes, they are getting uploaded for you people, so just practice those. Okay, also you can purchase the test series of Gradeup, okay, for RRB JE and SSC JE. So I hope these will give you adequate practice. Also from on your own, also on self study you should do. Okay, so thank you for watching this video, and just log in for more videos on Gradeup Gate channel. Okay, so have a very nice day, and see you in the next session.